MEP integrates in design process from the very beginning to the end. It is a critical component of the entire system. Without the integration of MEP, the facility won't function properly. It will not achieve what the owner needs and what the architect's vision is. So integration is one of the foremost things that needs to be done collaboratively in the beginning of the project all the way to the end. Considerations clients should think about when upgrading the buildings is what their long-term goals are. Decisions you make today are going to impact the future in 5 years, 10 years. You don't want to limit yourself now. When you consider where you are going with the project, what you need on the project, what your processes are, we need to know that right up front, and we can work together to actually come up with a perfect solution going forward.
So working with a integrated architectural engineering firm has great advantages, and that primarily is that if I have questions about coordination or client's design intent, I can simply walk over to the architect's desk and chat about what that is, and there's usually so much more information that I get when I'm discussing that with them than sending just a quick email saying, what would the client like in this particular room? I have worked for firms that are independent engineering firms, and the amount of time it takes to get feedback from the other disciplines is significantly longer for the firms that are engineering only. There's also more of a feeling of ownership. I feel that the engineers who are working on a project, since we're working right next to the architects, we feel that we're part of the team more, and so we also try to have better, not just coordination, but integrated design. So the challenges in the electrical field are primarily trying to balance cost with quality, also trying to coordinate, I'll say, physical aspects of electrical equipment. But then questions become, how do we balance the architect's desire to reduce the electrical room footprint compared to meeting codes, meeting flexible maintenance space requirements for the owner, as well as providing the ability to have future space and flexibility for the client. Aspects of electrical engineering that are often overlooked or underutilized are some of the behind-the-scene things. So every client interfaces with the lighting controls, for example, but the things that involve safety and code requirements are usually behind the scenes. And usually with electrical, those types of items are no news or good news. And so, for example, withstand ratings and fault currents are extremely important for safety in electrical system design, but they're rarely discussed or talked about. It's usually just anticipated that the engineer is going to handle them, and we do.
Building layout is very unique because we work in multiple planes. We work under the floor or in the ground. We work in the space that we are currently in, like for instance, a sink. Those things are literally in the view. So we have a physical and feature that needs to look good. Okay, so we have to work with the architectural on where things are being placed, what would the faucet look like, how is the faucet going to function, etc. Then we are working up above in the ceiling or exposed. So in order to get the water to the sinks or etc., it usually comes down the wall and it's hidden. So we have to make sure that we're working with the structural that you don't see for the most part in the walls either. You got to know where you are and think in 3D. Where our stuff, we've got to show it underground. We have to know where the fixtures are above the ground. We have to make all this stuff connect in Revit. Then we got to run it up through the wall, up into the ceiling, connect it there, and make sure we don't hit beams, ductwork, lights, etc. Properly sized systems is a very unique aspect because we have the code to follow. Now those are the minimums. But today's plumbing codes do not really reflect on what's going on in the real world as far as water reducing fixtures that we've had to endure. The whole aspect of sizing a system, you need to take into account what is the long-term effect of the building. Is it going to expand? Is it not going to expand? When you're dealing with a code minimum, that's exactly what you're getting, is the minimum. There's very little room to expand, but a lot of times you can go up to accommodate future connections or future expansion with one pipe size. You take the code minimum, you use your experience, you talk to obviously everybody that you can relating to what the future is going to be, and then you lay out your system accordingly. If it's oversized, then you could have an issue of stagnant water in the water pipes. So you don't want to overdo it, and you don't want to underdo it. There's a fine line that has to be found in order to do it right.